Swayam Prabha. Digital India. Educated India.
Welcome to the course on computers and manufacturing system. So, what was the limitation with manual process planning? Manual process planning, we need to have more and more men or manufacturing engineer who are involved in accumulating data over a period of time. So, what happened was computers started growing and the data has now started getting normalized and the data has been started now getting stored in a common place. Many data books have come into existence. Every country has their own standards, machining standard books they have started releasing. So, now what has happened, the computer is existence, the data book is now normalized and it is also put in a structured form. So, now this knowledge or this data can be converted into a knowledge. So, now using the advantage of computer evolution and the data books coming into existence, computer aided process planning has slowly become prominence and existence. People have slowly started accepting computer aided process planning. Now, let us see what is computer aided process planning. The evolution happened like manual, then going towards computer. During the last several decades, there has been a considerable interest in automating, because earlier it was country based. Now, people have started doing manufacturing cross countries. Now, people have started accepting, let us have a world standard rather than country wise standard, and parallelly the automation also has started evolving. So, considerable interest in automating the process plan function by computer systems started evolving. So, and slowly it was also becoming costlier to have knowledge based people in the industry, and they were also getting gradually aged. So, the alternative for manual process planning is computer aided process planning, CAPP. So, CAD started evolving, then slowly CNC started evolving. Now, what is happening is people have slowly started integrating these two and they have started talking CAM, and in CAM one of the vertical is CAPP. So, the manufacturers have been pursuing an evolutionary path to improve and computerize process planning in the following 5 stages. So, these are the 5 prominent stages which have been evolved over a period of time. So, in stage 1, manual classifications have started. So, you had so much of data, now there is so much of data, now you have to do a cluster algorithm of those data. So, what do you do? So, you try to cluster them based upon the shape, size or aspect ratio. You started classifying the data whatever you had, and then for each classified data you started establishing a standard process plan or a procedure. So, stage 1 was manual classification going on, and for each classification they started establishing a standardized process plan. Then computers were used only for maintaining those data. Okay, this data was there, these are the cluster formed, and for this cluster this is the process plan formed. So, now computer was used only to store and retrieve data. Then slowly the software algorithms started developing. So, the first step was leading towards variant process planning, the next one was leading to generative process planning, and the last stage is dynamic and generative computer aided process planning. In manual classification and standardization is the process. So, what I am trying to explain to you is, you have y axis and x axis, you have so much of data. So much of data are there. So, these data are nothing but different machining process and some parameters you can try to have. Now, what do I do with this data? I try to classify the data and form clusters. So, when I form these clusters, there is a similarity amongst these clusters. So, this is cluster 1, maybe turning operations, this is drilling operation cluster 1, then this is cluster 2. Okay. So, now this is what is manual classification of the data, and how did you classify them? You looked into the data whatever was there and then you grouped them. Okay. So, prior to CAP, manufacturers attempt to overcome the problems of manual process planning by basic classification of the parts into families. So, I always used to give this example to my students. Suppose you go and buy vegetables from the market, from a market which is along the streets or along the village. So, what we do is we try to get everything in a big bag, and now we come back home, and then what we do is we start classifying them according to their shape, size, aspect ratio, color and touch. So, we classify them into several families. So, for example, all tomatoes put together, all potatoes put together, all onions put together. Now, all onions are stored, and then the processing for onion is established separately, which is not going to be the same for cutting of tomatoes. So, now each are individual process plans established for each vegetable. So, that is what we have done. So, manual process planning by basic classification of parts into families and developing somewhat standardized process plan for that particular family. So, for all onions, for all potatoes, for all tomatoes. So, let us do a similar analogy here. If all cylindrical parts we try to do turning, all prismatic parts we try to do milling, all whole generation process you do drilling, and if the tolerances are high you do drilling and boring. So, that is what it is. For example, you have threads, internal threads, external threads. Internal threads, if you want to do on a cylindrical shaft, use a lathe machine. So, now what have you done? Looking into the part feature, you have classified, and the machining process is also established. Now, standard is established. Now, looking into your tool availability, workpiece availability, machine status, you try to decide what are all the process parameters you have to use. So, the standardization of process is nothing but turning operation, and tweaking to individual requirements will be done by a manufacturing engineer at the shop floor. But he at least knows, or he is at least given a lead that there is a standard process established for cylindrical shaft internal threading. Okay. So, when a new part would introduce, so you know you have now established all these things. When a new part comes, the new part is now having varying hardness, varying diameter, tool size might vary, tool angles might vary. So, now what we do is the process plan for that family would be manually retrieved and marked up and retyped, plus it will also be edited to meet the requirements. So, you will pull up that, look into the algorithm, fit in your data values, and then you try to make this as a standard established in your routing sheet. While this improves productivity, I do not have to start from 0, but I start from a certain level which can be easily tweaked, and the productivity improves. Productivity is nothing but minimizing the input to maximize the output. It did not improve the quality of the planning of the process, and it did not easily take into account the differences between parts in the family, nor improvement in the production process. So, these are the limitations. So, this is why from manual classification standardizing, we are looking for the second stage or the third stage to evolve in the computer aided process plan. In the third stage of the computer aided process plan is the initial computer aided approach evolved into what is known as variant cap. What is variant cap? Variant cap is nothing but the process plan is already given. This is the basic, and now what I do is I try to do some variation like changing speed, feed, depth of cut, okay. And suppose you have a drilling machine, you have one drilling machine which is CNC, now you want to change it to automated machine or you want to do it in manual. Suppose these are some of the changes which you do on the master process plan to meet out your requirements. These are variations which we do on the process plan to meet out the requirements. The variant is based on the group technology. What is group technology? Group technology is nothing but the family what you did, grouping of similar things based upon shape, size or manufacturing process. Group technology coding and classification approach. So, what is coding and classification? For example, let us take your roll number. Your roll number is maybe 16 12 003. So, what is this? This is your roll number. So, roll number in a factory is called as the part number. So, how do you decide the part number? That is what is a procedure called as coding. So, here if you look at the roll number, we can easily say, okay, you are Y16 batch, that means to say you joined in 2016 into a college, then you joined in the first semester, and 2 is maybe you are an undergraduate, or this 2 can be your department, maybe electrical engineering, and you have a roll number in the class as 3. So, now what I have done is I have taken some Ram, Sham, anybody, and I have coded him into a number which is called a roll number in your college, and when it goes to factory it becomes part number. Okay. Establishing this code is called as coding. It is not the computer program, but establishing a number for an individual part is coding. When you go to a part number in a factory, what will happen is by looking at it, they will quickly try to say whether this part gets into engine assembly and what is the current status of the part. So, the group technology coding does that for us. So, a variant cap is based on group technology coding and classification. Classification I have already told you, approach to identify a large number of part attributes or parameters. These attributes allow the system to select a baseline process plan for the part family and accomplish about 90% of the planning work. So, 90% is given here and only 10% tweaking will be done here. The planner will add the remaining 10% of the effort modifying or fine tuning the process plan. So, 90% is already established here and 10% variation is given, and this 10% is a number which is a ballpark figure number. It can go 20%, it can go even to 2%. So, please do not go by exact 10% values. So, it can change depending upon the new part coming. So, you have established something already available. So, you have to see that. For example, let me give another example. Every city in India has a pin code. For example, Kanpur pin code where IIT is there is 208016. So, now let us this coding is done by the post office earlier. Now, let us assume there is a new letter coming to the post officer or a postmaster. So, first thing what he does is he looks at the pin code, and that is why government always used to say when you write the address, please give the pin code, because pin code gives the postman to easily classify to which state it has to go. He will first look at this digit and then he will quickly say this digit goes to Uttar Pradesh. Even Tamil Nadu it is 6 it starts, if it is Bombay it is 1 or Delhi it is 1. So, you can see first looking at one digit he tries to put into the basket of all the posts which goes to Uttar Pradesh, and in Uttar Pradesh what we do is next these two digits will try to say which is the city. So, assume that this is given for Kanpur, this is just an analogy I am giving. So, now looking at this, so it has already come into one dabba. So, that dabba tells about Uttar Pradesh. Now, it has reached Uttar Pradesh and now you have to say in Uttar Pradesh where it has to go, then you have put Kanpur. So, now it just puts in the dabba of Kanpur, and now In Kanpur, they have again classified it, they have coded it. They have coded it into several numbers have been given for several areas. 16 is given to Kalyanpur. So, just by looking at it, the postmaster will put it to a bin which comes up to Kalyanpur or up to IIT. Okay. So, this is coding, this is done, and when a new letter comes, what happens? It is easy for the postmaster, rather than looking into all the address, he just looks at the pin and classifies. That is what is done by this group technology, coding and classification. Moment it has come to, it is coded and classified, 90% of the data is given, the planner has to work only on 10%. So, he reduces his time, there will be no mistakes, and there will always be a scope for improvement. The fourth stage is going to be generative cap. So, in variant cap what happens? There is a part family, and that for that part family there is a process plan well established. Okay. In generative type cap what happens is, I know the basic knowledge. For example, let us assume you are driving a car, you know the function of a steering, you know a function of an accelerator, you know a function of a brake and a clutch, and you know what is the gear supposed to do for you while you drive a car. So, all these basic things are done. Depending upon the road conditions, you keep playing with these three pedals, steering and gear, to meet out to the requirements. So, this is generative type method. So, in generative type, all the basic tables are established and there is no fixed program already given. Based upon the input data, these are decision tables. Based upon the table, now what happens is, you try to take a call and then you try to develop a process plan. So, what is the advantage? Rather than trying to say that if you are driving in a street like this, use this, you just say, I am teaching you all the basic conditions, you are aware of all the basic conditions, now you coordinate between the three decision tables and come out with a process plan. So, the advantage is, the server, the knowledge whatever is stored is not exactly focused to one requirement, it is now made generic. So, when it is generic, what happens? There is a lesser amount of data stored, but there is a good algorithm evolved. So, now when a new product comes, it is very easy to evolve or generate a plan, or in the previous one already existing, tweaking, that is variant. Generative is, I know the basics, I know this is what it has to do, I generate the plan. So, here it is more precise and it is more generic. Suppose in the variant, if a new part comes and nothing is already available, then the process planner has to start from 0. But here, since he knows the logic, so what will happen? It will quickly help him in evolving. So, minimum knowledge space, maximum accuracy it can come, and when new products come, generative cap is more useful than variant cap. At this stage, the process plan decision rules are built into the system. Just like what is decision table? Decision table is something like your Excel file. You have X and you have Y. So, there are suppose three different, you have several columns, several rows, and you can have a frame on frame on frame. So, this will give the knowledge to the next frame, from that frame to the first frame. So, the first frame will give you all the options and you will try to get the output. These decision rules will operate based on parts group technology or features technology coded to produce a process plan that will require a minimal manual interaction and modification. So, this is the latest, and this is what nowadays computer aided process planning is doing. What is dynamic generative cap? While cap systems are moving more and more towards being generative, a pure generative system that can produce a complete process plan from part classification and other design data is a goal for the future. So, even without a manual intervention, that means to say the options are given, verifying the options and then going, the system itself generates and give, that is called as dynamic generative cap. So, even in generative cap what happens, there can be 4 options given, and we are only talking about a very small feature here like turning, drilling. But when you look at a die which is made for injection molding, there are several features, and these features has to be done in a sequential manner. And when you do it in a sequential manner, you have to take reference of previous one and then go. So, now here comes a challenge, where to take reference, how to take reference. So, even in generative cap, many a times there can be 4 options given to the planner to evolve, but in dynamic what we are saying is not even that variation should be there. Exactly give what is the output and start getting the output. This type of purely generative system in stage 5 will involve the use of artificial intelligence type capability to produce process plan as well as be fully integrated in a SIMS environment. So, this is nothing but using AI, ML and DL, artificial intelligence, machine learning and deep learning. Okay. These are the buzzwords which are now talked more in manufacturing. When we are looking for a SIMS, computer integrated manufacturing environment, these techniques are nowadays exhaustively used in process plan. A further step in this stage is dynamic and generative cap, which would consider plant, machine capability, tool availability, then work center, equipment loads and equipment status in the developing process. In dynamic generative cap also implies the need of online display of the process plan on a work order oriented based to ensure that the appropriate process plan was provided to the shop floor. So, in here when we talk about dynamic, we are trying to keep customer requirement also, customer requirement and the current loading of the factory. Loading of factory, that means to say what are all the machine loads and how are these done. So, that what happens, we start looking forward for optimizing machining center usage, tight integration with the manufacturing resource planning system. So, we are now trying to integrate a shop floor with your office, where they are involved in more of sales and service. So, this interaction is going to happen. Now, why is this important? Looking into the shop floor, looking into the availability of the machine, looking into the availability of the parts. Now, you try to talk to the office of sales and say this is possible, this is not possible, and moment they say why don't do this, then immediately the shop floor should be able to tweak the part program, the availability of the tools such that they meet out to the requirements. So, tight integration with the manufacturing resource planning system is needed to track shop floor status and load data and assess alternative routing vis-a-vis the schedule. Finally, this stage of cap, stage 5, would directly feed shop floor equipment controllers or in a less automated environment display assembly drawing online in conjunction with the process plan. So, this is the latest, people are working on it. Till the 4th stage, it was only shop floor control, and computer which is in the shop floor will try to give a data to the process planner. But in the last stage, dynamic, it is now going to be completely automatic. And here it is going to look at the availability of the tools. Many a times in process plan, he might say do this, but he might not be aware of the tools which is there with him, the workpiece quantity and stock. What is quantity? What I mean to say is what is to be done, and stock is what is already there and raw materials available with him. So, now in dynamic generative process plan, all these things are done. Why? Because if one good machine is already loaded to 100%, then they will look for alternative machines which are not so good in producing quality. Now, but tweaking some fixtures there, you can try to produce. That evolution of knowledge is called as dynamic generative cap. So, if you want to put the computer aided process plan in a schematic diagram, we have design knowledge, this leads to CAD system, and this goes to 3D CAD modeler. Okay. So, this is one vertical. Next is process planning knowledge. This will lead to CAPP, computer aided process plan, and this gives you a process plan. The other one is manufacturing knowledge. This goes to CAM and this goes to NC code. So, these are the results, and the top one is the knowledge base. So, design knowledge, process knowledge, manufacturing knowledge leading to CAM, process planning to CAP, and design knowledge to CAD. So, from here modeler, process plan and NC code we generate. So, let us see the framework for computer aided process plan. So, here we will have organizational planning system, then we will have MRP, which is nothing but material resource planning, and we also talk about capacity planning. Then we will have CAM, okay. So, this we will have actual data, then this is production control. We will have CAD here, this is going to talk about product design, CAD, and this is going to give me geometric data, and from CAD I also get the part list. I get a part list. So, here what is there in the factory is going to be machine, tools, fixtures, gauges, etc. So, this is going to be cap. So, there is going to be an interaction between cap and cam, and here you will have a straight line which joins these two fellows, which is nothing but a process plan. Okay. So, this will try to talk to production control, and CAP will try to talk to NC program. You see, everything is getting integrated inside a factory environment. So, this will be the frame, total frame. So, you have organization planning system, from there it will go to MRP, from MRP you will go to CAM. So, this is nothing but the production order. and then you will have resource planning. We will see all those things in little details as and when the course keeps going. What is MRP, what is resource planning, all those things. But currently you should understand this is the framework of computer aided process planning, wherein which we get the data from materials resource, process planning, CAD. So, this data comes CAP, and CAP data is given to NC program, and this keeps talking to each other to develop a process plan for machining a part or developing a part. So, whatever we have studied till now, if we want to put it in a block diagram, we have a process plan which is manual process plan and a computer aided process plan. The computer aided process plan now is classified into variant, hybrid and generative. Now, let us look into computer aided process plan. Computer aided process planning are designed for retrieval or variant system. Next is generative system, we went through it little bit. Then the last one is going to be hybrid systems. So, what is generative type CAP? Based upon the group technology and part classification and coding, a standard process plan is stored in a computer file for each part code number. So, a standard plan are based on current part routing in use in the factory or on an ideal plan prepared by each family. So, already whatever is there which is stored, you just call. So, it is basically if and then statements will be used to get. So, it is basically an expert system will be used here. If these are the conditions, then lead to this answer. So, you will have a knowledge base, or you will have a knowledge base, you will have an inference engine, and then you will have input given. If there is a traffic congestion over Delhi, and if the flight is if there are lot of flights land up, and if there is a visibility problem, then please do not start the flight. So, that is if and then. Okay. So, retrieval system CAP is basically working on if and then system only. So, here what will happen is a standard is already established. So, you put the part number and call for the part number, then immediately the process plan will be shown in front of you and you start working on it. Here there is no knowledge, whatever is available there you bring, and when there is a new product coming, it will be very difficult for you to establish and run. So, it will work on only retrieval, whatever is stored it retrieves and you start working. A standard plan are based on current part routing in use in the factory or an ideal plan prepared for each family. For each new part, the standard plan is edited if modifications are needed, also known as variant CAP. Retrieval or otherwise known as variant CAP is almost the same. The system logic involved in establishing a variant process planning system is relatively straightforward. It is one of matching a code with a pre-established process plan maintained in the system. Many a times when you go to a textile shop, when you try to go to a cloth shop, so what you say is, you say, here is a cloth I have, can I get a similar color cloth? So, immediately what the person does is, he keeps in your left hand or right hand the cloth what you have given to him, goes to the showroom or goes to a shelf where there are similar colors identified, he places it besides each other and then tries to pick up the closest match and say, please sir, see this. So, this is the way variant CAP also works. You have given something, the computer will quickly try to match it with already existing one, and then whichever closely matches, it pulls out from its library function and displays it in your front. This initial challenge is in developing the GT classification and coding. How do you classify it? Because when I gave you an example of a textile cloth, okay, it was easy, but in a factory what is there is, you have to establish a coding system. So, now you establish a coding system and there are several codes which are already there. For each code is nothing but a part number, each part number has a process plan, you just pull out that and start using. So, initial challenge is in developing the GT classification and coding structure for the part family and in manually developing a standard baseline process plan for each part family. Initial it will be difficult, then on it becomes easy. The first time you have to establish, there it is a challenge. So, when we look at a retrieval cap system, a new part comes. Okay, forget first the new, okay, let us take it as a new part. New part comes inside. So, what it does is it derives a GT code number for the part. A new part comes into. So, what it says is please give the code for the part. You can't give the shape of the part. You have to say a code number. So, put the code there. Okay. So, you get an admission in a college, the first day what you have been given is a roll number. Why? Henceforth, when in your duration of stay in the college, you will be addressed as against a roll number, not against your name. So, it will be given as a code number. So, for example, there are some 8 branches and you come and opt for mechanical. So, now already there are mechanical students in your senior batch. So, you have to follow the same coding pattern for you except for a change in the year of joining. That is what you do. So, derive a GT code number for the part. Then search part family file for GT code number. Look into mechanical, last year what have you given, pull it out and then take the same, change whatever is required. So, here what we do is part family our files are looked into, and then what we do is we try to look into the preparatory stage whatever you have done earlier. Selecting coding system and forming part family, which you have done already for mechanical. So, you pull that from that and then you see. So, standard part family files and standard process planning files are retrieved and it is given. So, based on that you try to retrieve the standard process plan, edit process plan and again compare it once again with the standard. Then now you have a process plan formatter and then you have a routing sheet which is established. And if there is any changes to happen or other applications to be done from the process plan formatter, you try to do. For example, this applicator is calculating the cutting time, calculating the cycle time. So, all these things are done in the retrieval cap system. So, in a retrieval cap system or a variant cap system, you can see a new part coming, a GT code getting established, a process plan retrieval is done, a process plan is retrieved. When you start doing this process plan retrieval and editing, you pull out something from the master plan and then you start editing, so that you try to meet out to the existing part. If the file does not contain a standard process plan for a given code number, the user may search the file for a similar code. I do not get the exact code, but now what I do is I look forward for a similar code. So, now similar code number is taken out, you edit it to your requirements and finally, you make a formatter. The formatter may call other applications like determining the cutting conditions, calculating the standard time, computing cost, all these things will be done and finally, you will try to give the generative cap gives the final option. So, in generative type what happens, rather than retrieving and editing an existing plan from the database, the process plan is created using systematic procedure that might be applied by a human planner. This is what I said, driving a car. You have been taught to drive a car, the logics told, the inputs given. Now, depending upon the situation, you try to maneuver and you try to play with the tree and try to do it. In a fully generative cap system, the process sequence is planned without human assistance and without predefined standard plan. So, here there is not a set condition told to you, but the logic are taught to you. Designing a generative cap system is a problem in expert system. Expert system variant retrieval works on the logic of if and then. If you have a new product and if you can somehow understand the new product and put if condition, then comes. Expert system works exhaustively very well in the variant and retrieval system. But in generative type, you are supposed to use artificial intelligence, neural networks, fuzzy logic. So, the particle swap algorithm and colony algorithm, these are all used, wherein which the data is there, the algorithm is taught and the evolution of result is different. So, the computer program capable of solving complex problems that normally require a human with years of education and experience, which is what is done in generative type. In generative type, I told you this is a part, new part coming into, these are all the process plan logics. So, this is where we use AI slash, in AI we use ANN slash genetic algorithm, PSO, then people talk about ant colony optimization, the fuzzy logic. So, all these things are brought in here, and all these things uses, these are the database for this algorithm to work, and then what you get out is a process plan. The first key to implement a generative system is the development of a decision tree appropriate for the items to be processed. Decision tree. So, this is what I told you, we teach you basics. These decision rules are specified under decision tree, computer language involving logical if then type statements or artificial intelligent approaches with object oriented programming. This is what is called OOPS, object oriented program, OOPS, which is exhaustively used in database softwares. Why? Because you have so much of data, how are you going to logically store the data such that the program can quickly work and retrieve and bring you the output. The nature of the part will affect the complexity of the decision rule of generative planning and ultimately the degree of success in implementing the generative CAP system. The majority of the generative CAP system implements to date have focused on process planning for fabrication of sheet metal parts or less machine complex part. In addition, still it is going, still it is evolving, generative has not reached its maturity. In addition, there has been significant recent effort with generative process planning for assembly operations including PCB assembly. Sheet metal is, why it is so prominent in sheet metal is 2D profiling. So, it is thickness is too small and along the thickness there will not be any variation, x and y there can be a profiling or there can be a geometry. But whereas when you do machining of a 3-dimensional object, there is along the z direction there is a variation. So, that makes the life more complex for generative type. So, it is exhaustively used for sheet metal and PCB assemblies. The second key of generative process planning is the available data related to the part to drive the planning. Simple forms of generative process planning systems may be driven by GT codes. So, GT or features technology FT type classification without numerical code may be used in derive CAP. So, this approach would involve the user responding to a series of questions about the part. So, you are asking questions and you start putting all those questions in that. So, then answer to those questions, then finally what comes out will be a generative CAP, which eventually will work on feature oriented data is captured in a CAD system during the design process. This data can directly drive CAP. So, in CAD also I was trying to talk about feature recognition or recognition. So, if there is a feature, so in this feature eye are feature, nose is a feature, mouth is a feature. For each feature there is a process plan already established. So, when you put this entire object into a CAD, though quickly it will extract those data, then go to feature based process plan which is already there, which will be in logics. So, it will quickly pull out all those things and come back and tell you what is the best process plan to be used. So, this is generative type process plan, and there is a hybrid which is semi generative CAP, which is in between variant and generative. Hybrid system might use variant GT based approach to retrieve an existing process plan and also can be used generative technique for modifying the process plan to suit. So, neither variant nor fully generative, hybrid CAPs are used. Today exhaustively what is used in SIMS environment are hybrid CAP system only. So, these are some of the variant and generative CAP systems which are available in the market today. So, CAP system is CMPP, Gen Plan, GT CAP, CAPS, MIP LAN. These are all the different CAP systems which are commercially available, and I have said for what type of shape. It is all geometric for all, it is rotational and prismatic, it is only for rotational. So, here it also tells you whether it works on generative type or variant type. Then it also tries to tell you the characteristics and commercial situation, what are the interfaces to be used for this. Then what is the program which is used. Lisp is used in AutoCAD also, Lisp. So, you can write a library in AutoCAD. So, that is we use Lisp or Fortran 77 or Prolog is used for writing those programs in the interface, so that it can use the software to use. Who are the developers also I have given. So, some are still used in the developed in the universities, some are developed in the see here you can see a US based, here you can see a university based. There are some industries are also playing a major role in it. So, even today there is nothing called 100% generative perfect CAP system, they are all still in the hybrid stage towards evolution. So, the CAD-CAM integration of CAP feature, a frequently overlooked step in the integration of CAD and CAM is the process planning. CAD system generates graphical oriented data and may go so far as graphical identifying metal etc. to be removed during the process. In order to produce such things, an NC instruction from CAM equipments, basic decision regarding equipment to be used, tooling, operation sequence are to be made. This is a function of CAP. So, we are talking about CAD, we are talking about CAM, and we are talking about a function of a CAP. Without some elements of CAP, there would not be such a thing called as CAD-CAM integration. So, between CAD and CAM, CAP is the biggest vertical which has to play a role in understanding the drawing, converting into a manufacturing part. Thus, CAD-CAM systems that generate tool path and NC programs include limited CAP capabilities or imply a certain approach of processing. The CAD system also provides graphical oriented data to CAP system to use to produce assembly drawing. Further, this graphical orientation data can then be provided to manufacturer. So, this is how a CAD and a CAM is integrated by using CAP. So, here let us just see CAD here, this is CAD where we have studied all the graphical thing, then we have a CAP here, then we have a CAM here. So, the function of a CAP is going to be, it gives you a synergy results in when CAM is integrated with CAD or CAM system. So, CAP becomes a direct connection between design and manufacturing. Okay. So, this is the way CAP features in between CAD and CAM. This is very important. So, if we look at it, so we have a design layer, we will have a manufacturing layer, then we have a process planning layer, and then we will have again a manufacturing layer. So, this one is manufacture, I will change it, this is manufacturability, manufacturability layer, and which is nothing but a macro layer at a macro level. So, here you will have conceptual design A, you will have embodiment layer or design. C, you will have detailed design. These are all the design layer. In manufacturability layer or macro layer, we will have a selection of manufacturing process. Okay, and then B, you will have manufacturability analysis. So, this is a vertical, this is a second vertical. So, here in process plan, we will try to do a selection of operation, then B, we will try to have operating sequence. These are the information we will get. C, we will try to get optimal parameters, process parameters. In manufacturing layer, we will try to get A, scheduling, B is shop floor control. So, all these things are linked. A two-way communication will happen between design layer, manufacturability layer macro level, then process planning layer and manufacturing layer. So, you will have several layers. So, this is how a CAP is getting integrated into a CAD/CAM system in real time when we talk about computer integrated manufacturing. So, CAP will give you routing sheet, will give you NC program, will give you time estimate. What CAP gives. And what is given to CAP is product data, machine tools, cutting tools. These are all the inputs which we give for CAP. Then we give fixturing device, then we give inspection device. These are all the inputs. So, we are talking today about the dynamic one, generative CAP. So, you see all these data are given. Then you will also give the shop floor schedule. Status. So, all these things are given to CAP. These are all the in which is given and these are all the out you take from a CAP system. So, when what are the components of an expert system? You, as I told you earlier, you will have a knowledge base. This is KB. Knowledge base, you acquire data from all people in terms of questions over a period of time, whatever it is. A technical knowledge of manufacturing and logic used by process planner must be captured and coded in a computer. So, this is called as knowledge base. So, knowledge base means once you acquire all these things, it has to be stored as against a number. So, that number is nothing but a part number, that is nothing but a part number, and part number is nothing but a code which is done by GT. Okay. Then computer compatible part description, the description must contain all the pertinent data needed to plan the process sequence. Then inference engine, knowledge base, then it is an inference engine. Knowledge base, you collect data from all, these are input. This is knowledge base is stored. Then inference engine, here you write a program, software. Okay. And then what you take it out is the output. The algorithm that applies the planning logic and process knowledge containing in the knowledge base to a given part description is done in a inference engine. And then finally, you get the output. What are the benefits of CAP? So, the process rationalization and standardization happens. So, because of that, what will happen is you do not have to store many part numbers, but now you will store only lesser part numbers. So, you can quickly go retrieve the data, edit the data to meet out your requirement. CAP leads to a more logical and a consistent process plan than traditional process planning. So, traditional process planning, every part number will be there, it will have all the sequence. Now, it will occupy a huge database. So, when it is there a huge database, the error is prone to happen, the storage space becomes, the retrieval becomes difficult, then you need a huge server space to use it. So, increasing productivity of process planner can happen by using CAP, reduced in lead time, improves legibility over manually written routing form can happen, incorporation of other application programs can be integrated with CAP, so that you do a cost estimation, work standard and a NC part program can be done. In detailed survey of 22 large and small companies using generative type process planning, 58% of the reduction in the process planning efforts have been done, 10% in the labor cost, 4% in materials, 10% in scrap, 12% in saving tools and 6% reduction in work in process. Work in process is nothing but you are trying to between one station, the other station, the part is moving. From the start before the end, the parts which are lined up are called as work in progress, which cannot be sold, but is existing in your factory, which is not also can be stored in terms of inventory. It is in between it. Inventory can be a semi-finished process or a part. Benefits of CAP. So, the traditional approach to launch a product, an approach to product design that tends to separate design and manufacturing engineering was the traditional approach. The product design develops a new design, sometimes with small regard for the manufacturing capability possessed by the company. There is a very little interaction between the design engineer and the manufacturing engineer. Traditional approach when a new product is launched. When the emphasis of planning for the future is distinct from the process planning, because it is concerned with products being contemplated in the company's long term plans rather than product currently being designed and released. So, the emphasis of planning was further done at this stage. So, now this led to advanced manufacturing planning attempts to forecast the new products that will be introduced in the 2 to 10 year future will also be done by using of this CAP. So, how many new products have come? Based on the new products, I will understand, okay, the product life cycle is going to be short. So, I have to prepare myself for the next possible variations, and to determine what production resources will be needed to make those future products, we use manufacturing planning. So, in a schematic diagram, if I have to represent the advancement of planning, it will be future products, then it will be advanced manufacturing planning. This has two classifications. One is new technology, the other one is existing manufacturing capability. Then this will give to future manufacturing capability. Okay. So, this advanced planning will look at new technology getting evolved, new technology evaluation, investment, project management, then it is facilities planning. All these things are for future they are doing, and then finally you will get manufacturing research. Okay. So, this is new product process strategy. So, you have all these datas, these are flowing like this is flowing like this. So, if you see that advanced manufacturing planning today is trying to take all the new technologies, investment, facilities, manufacturing, what is the lead time, how is the product going to perform, what is customers feedback, all these things are getting integrated. Earlier at some point of time we were talking about CAD and CAM, now we are trying to talk comes CAP in between. Now we are trying to talk about also trying to bring in ERP, enterprise resource planning into the CAP, and now CAP is getting moved to the next era of dynamic CAP. So, where it also looks at how are the new products going to perform, what is the technology, and how is the old technology information used to change. For example, as and when the new evolution of smartphones keep coming, quickly a individual tries to learn and then starts using the smartphone. In the same way, CAP, whatever was already existing, people are using it. As and when the new thing comes, they learn it and then they start using it for the futuristic requirements. So, the activities which are involved in manufacturing planning, new technology evaluation will happen, and then you will have investment project management, facilities planning, and manufacturing research and development. So, all these are the activities in advanced manufacturing planning. So, to recap what we have studied in this process planning is, we studied what is process planning, who does process planning, what is a route sheet, then what are the two approaches in computer aided process planning, what are the benefits, and to conclude, what are all the advanced manufacturing planning which is happening in the latest industries today. So, these are the references which we have followed, and thank you very much.